Today I'm going to be demonstrating how to install recessed lighting in a traditionally framed home in the United States. This applies to just about any single-family wooden frame structure, which is the vast majority of homes throughout the country. The reason that I decided to film this particular install is because I'm doing it on the vaulted ceiling that you see in this room, which is a bit unusual. Now, chances are, if you're watching this video, you're installing recessed lighting on a flat ceiling, and you may also be working in a finished ceiling, meaning that the drywall is up. Because of that, at various points throughout this video, I'm going to stop and explain how things would be different under those circumstances. But generally speaking, things are going to be very similar. The main difference is that I need a special can to accommodate the slope. Anyways, if you're renovating your house as I am mine, then I hope that you find this content useful. So with that being said, let's do it. A good place to start with this install is to talk about the different cans that you're going to come across when dealing with recessed lighting. Broadly speaking, there are two different types. There's new construction and there's old construction, and I have examples of both here. This can right here is a new construction can, and this actually is the can that I'm going to be using in this renovation. In contrast, these are old construction cans. So what's the difference? Well, the difference basically comes down to, is this can going to go into a finished ceiling, meaning the drywall is up, or is it going to go into an unfinished ceiling, meaning that the drywall is down? In new construction, so when you're building a new structure, you would always put the cans in before the drywall goes up, and that's where the term comes from. This new construction can is intended to be secured directly to the framing using those legs there. In contrast, an old construction can is secured to the drywall using these tabs here. The way that works is you just make a hole of the proper size, you put the can in, and then these tabs grab the drywall, and it's very simple. If you have the option of doing that, I would definitely recommend it because reinstalling drywall is a real pain. So in other words, if you're able to run the wiring without taking the drywall down, that's what you should do. So when you're shopping for recessed light cans, you basically have to ask yourself, is this going into a ceiling with drywall, in which case you'd want to use an old construction can, or is this going into a ceiling that is unfinished, as if it were new construction? In that case, you'd want to use a new construction can. While I have these cans here, I should also mention the fact that there are different sizes of recessed lights. By far the most common is 6-inch and 4-inch, and once again I have examples of both. This is a 6-inch new construction can, and this one is special because it can accommodate sloped ceilings. We'll talk more about that in a few minutes. This is a 6-inch old construction can for flat ceilings, and this is a 4-inch old construction can, once again for flat ceilings. Now, you're probably wondering, when should I use a 6-inch can and when should I use a 4-inch? Well, the answer to that question is largely an issue of personal preference, but there is a rationale for one over the other. I'll explain how I make the decision. When I want floodlighting, so when I want to illuminate an entire space, I generally use a 6-inch can. For example, right now I'm standing in what was and what will someday again be the kitchen, and I'm standing under 6-inch new construction cans, and you can see that they provide a relatively even lighting. I would use a similar setup for a bedroom or for the living room that you'll see me install this can right here in. Now, if I want to provide more of a task lighting, a more focused lighting, that's when I would consider using a 4-inch can. For example, over the sink in this kitchen, I installed two 4-inch cans, one on either side. That will provide really nice task lighting for washing dishes. 4-inch cans are also good for smaller spaces like closets. But once again, it really is an issue of personal preference. If you wanted to light your entire house with 4-inch cans, you could do it. You would just need more of them and the install would be harder and cost more money. But it can be done if that's what you really wanted to do. The decision ultimately is yours. Let's now talk about can placement, which is a bit of an art, but just like with the decision between 6-inch and 4-inch cans, there is some science behind it. You can see that I've drawn a rectangle on the screen, and the dimensions on this one are 10 by 12, or 120 by 144 inches. This is a pretty standard size for a bedroom, and if you scale it up a little bit, it could be a living room or a kitchen. When dealing with a space like this, you're probably going to want a can in each corner. As a general rule of thumb, the center of the can should be about 20 to 25% of the way into the room, which I've represented with the shaded area. Every room is going to be a bit different, but for the most part, if you place the center of the cans within this area, and obviously you want to keep it consistent with each corner, then the install will look just fine. Let's now talk about the electrical side of this installation, which I consider to be part 2. Part 1 was the physical installation of the can in the ceiling, which we've already covered, so now we can move on. Here we're just going to talk about the components. In a few minutes you'll see how everything actually connects together, but here we're just going to talk about everything individually. So let's begin by talking about the wire that we're going to be using. This is the standard for residential lighting applications. It is 14/2 NM-B cable, also known as 14 gauge Romex. Let's break that down a bit. The 14 refers to the fact that the conductors are 14 gauge, meaning that they're rated for 15 amps. The 2 refers to the fact that there are 2 current carrying conductors, the black wire and the white wire. There is a ground in there, the bare copper wire, but that's not meant to carry current. It's there just for safety. The NM refers to the fact that there is non-metallic sheathing on the wire. This is different than, say, an MC cable, which you would find in commercial applications. And lastly, the B is just the heat tolerance of the insulation. The insulation on this wire is rated for something like 200 degrees Fahrenheit. And if your house gets anywhere near that temperature, you have much bigger problems than the wire that you use to connect your recessed lighting. Anyways, the next thing that you're going to need are these 1/2 inch NM cable staples. These secure the wire to the framing and they just hammer into place. Next, you're going to need these clamp connectors, specifically NM 3/8 inch clamp connectors. These both protect and secure the wire as it enters the recessed light housing. You may need some wire nuts to wire everything into the switch box, more on that later. And lastly, you're going to need a switch. I really like these Leviton dimmer switches, and yes, I am assuming that you're working with dimmable recessed lighting since most lighting these days is dimmable. These dimmers work great. It's the Leviton 6674, and if I had to recommend one, I would recommend this one. We're just about ready to begin the installation, but before doing that, we should talk about some tools. You're obviously going to need a measuring tape and a hammer, that goes without saying. You're also going to want a utility knife with a sharp blade. This is used for removing the outer jacket from that Romex. To remove the insulation from the inner conductors, you're going to want a pair of wire strippers. These ones by Milwaukee work great. Now, this next tool is optional. I say that hesitantly because I wouldn't want to do the job without it. But these are lineman's pliers. They have a pair of side cutters that works great for cutting Romex cable, and these wide jaws are really good at twisting wire together. We're going to have to do that when we terminate the connections in the switch box. Yeah, you can use a pair of channel locks, but it doesn't work nearly as well. Now, there is actually one more tool, and that's a drill with a 1/2 inch bit. If you need to make some holes in your framing to run the wire, that's what you're going to want to use. At this point, if this install were occurring in a flat ceiling, I'd be ready to put the cans into place. But as you know, this install is occurring in a vaulted ceiling, and for that reason, there's one additional step. Specifically, I need to figure out what the slope or pitch of the ceiling actually is. The reason for that is that cans for vaulted ceilings have a special adjustment that allows the light to point straight down, which is what you want. But in order to properly make that adjustment, you have to first figure out what angle you're working with. So right now, I'm going to show you a very simple and easy way to determine that. Just so we're on the same page, let's briefly talk about roof pitch. In the United States, we always talk about roof pitch as some number over 12. This just refers to the amount that the roof rises for every 12 inches of run. Let's look at 2 examples and then you'll see exactly what I mean. Here I've shown a diagram of a 4/12 roof pitch, which is very common for homes here in the Southwest United States. You can see that the roof rises vertically 4 inches for every 12 inches of horizontal run. Here's another example, this time of a 12/12 roof pitch. This is extremely steep and very uncommon in this part of the country, but you get the idea. Alright, here's how I'm going to do this. First I need to pick a rafter. Any rafter is fine. I'm using this one. Then I'm going to measure 4 feet from the wall up the rafter, and at that point I'm going to put a nail. From that nail, I'm going to hang this string that I've weighted down with 3 washers. And then I'm going to measure the distance between the wall and the string. And using that measurement, I can calculate the pitch of the roof. Don't worry, this is going to make perfect sense in just a minute. Okay, we're at 44 inches. Here's a picture of the triangle that I just created with the string line. Side A is level with the ground, side B is vertical, and side C represents the rafter. As we discussed previously, the roof pitch is given by the length of side B divided by side A. Since this is a right triangle, we can calculate B using the Pythagorean theorem. This gives a value of 19.2 inches. So the roof pitch is 19.2/44, which equals 0.436. Now, as I mentioned before, we usually talk about roof pitch as some number over 12, not as a decimal. If we convert common roof pitches into decimal form, which I've done in this table here, we can see that the pitch of this roof is very close to 5 over 12. So that's the value that I'll use when adjusting the cans. Here's a closer look at the inside of one of the cans for the vaulted ceiling. You can see that on the right side there's an adjustment that ranges from 2 to 6. That's the angle adjustment for the light socket. Right now the can is set for a 4 over 12 ceiling. However, after loosening this set screw, the angle can be decreased by moving it towards the 2 or increased by moving it towards the 6. For my cans, I'm going to set them just slightly above 5. This will ensure that the lights point straight down once the cans are installed in the vaulted ceiling. Before installing the cans in the ceiling, there's one final thing that we need to do, which is install these clamp connectors here. This is easier done on the ground than when you're working on a ladder up in the ceiling. These clamp connectors allow the electrical wires to safely pass into and out of the junction box, which you can see right here. And if I take the side door off, you can see the individual conductors inside. There is a black, which is hot, a white, which is neutral, and a bare copper ground. The clamp connector just installs into one of these knockouts here, and there's also knockouts on either side. The way this works is you remove the knockout with a screwdriver, put the clamp connector into place, and secure the screw ring on the bottom. And at that point, the wires can pass into and out of the box. Now, before doing this, there's one thing that you need to consider, which is where is the can going relative to the ceiling joists or rafters? If, for example, the can is going to be flush up against a piece of framing on this side, you don't want to use this knockout because you can't get the wires in. Instead, you'd want to use one of the other sides. So before installing your cans, just think, where are they going relative to the framing, and use the appropriate knockout. Like I said, it's much easier doing this on the ground than when you're working in the ceiling. Right now I have the can exactly where I want it, so I'm going to tighten this set screw here to lock the legs. All right, I have all the wires run between the cans, which means that now it's time to hook them up electrically. I'm going to be demonstrating how to do that on this lead can here. And what I mean by lead is that it takes power directly from the switch. That power comes in on this wire here, and then power leaves to the other cans on this wire. But regardless, the process is the same for all of the cans. Basically, what you have to do is you have to connect the black wires to the blacks, the whites to the whites, and the grounds to the grounds. And you do that using the push connectors in this junction box here. Just watch, it really is easy. All right, now we're ready to wire up this switch box, and once we do, the recessed lights will have power. Now, as you can see, this box is going to have 3 switches in it. One for the recessed lights, one for the fan, and another for an outlet that is switched. Making all this work requires 4 Romex cables, so let's talk about that now. The first Romex cable on the left here is a 14/2 cable that carries power in. So remember, a 14/2 cable has one black, which is hot, a ground, and a neutral. And in this case, the black wire connects directly to the breaker in the subpanel. This 14/2 cable here is for the recessed lights. We've already talked about that. This 14/3 cable is for the fan. I've mentioned that as well. And this final 14/3 cable is for the outlets in the room. All of the non-switched outlets get power through this black wire, and the switched outlet gets power through the red wire. Now what I'm going to do is I'm going to show you exactly how to wire this up step by step, and chances are this box is a bit more complicated than what you have. So if you understand how this works, you should be able to wire up pretty much any switch box that you come across. Alright, I'm going to start with the white wires, which is where I always start in a switch box. The reason is that the neutrals in almost all cases just get tied together and pushed to the back of the box. In other words, the neutrals are not switched. If you for some reason find that you want to connect the neutrals to your switch, there's a very good chance that you're doing something wrong. Like I said, you're generally going to just tie them together and push them to the back. So let's do that now. Okay, next up is the grounds. Just like with the neutrals, the grounds all get tied together. However, there is a very important difference, which is that the switches need to be grounded. Generally speaking, there's 2 ways to do this. The first way is most common with dimmer switches and fan controls, and that is a piece of stranded wire that is stripped at the end. This stripped end just gets wrapped around the grounds after they've been twisted together. Very simple. Other switches, though, have a different way of grounding, and you can see that here. This is a screw terminal. In order to make this work, I need an additional piece of wire, which I have here. This wire is going to get twisted together with all 4 grounds in the box. And then at the other end, I'm going to put a loop, and that loop will go around the screw terminal and allow me to ground the switch. This will all make perfect sense after you see it. Finally, we have to wire the hots. One thing that all these 3 switches have in common is that they all need to connect to power in, so that's a good place to start. Power in is this wire right here. The dimmer switch and the fan control both have a piece of stranded wire that'll just wrap around power in, so that's really easy. But with the other switch, just like with the ground, I'm going to have to add an additional piece of 14 gauge wire to accommodate the screw terminal. Now we're going to connect the dimmer switch to the recessed lights. And at this point, we need to briefly talk about the difference between a single pole and a 3-way switch. If your recessed lights are controlled by only one switch, as is the case here, then you have a single pole setup. However, if there are 2 switches controlling the lights, then you have a 3-way setup. Here's why this matters. In a single pole setup, you're just going to use this one red wire coming off the switch and connect it directly to the wire going to the recessed lights. However, in a 3-way setup, there's an additional wire, which Leviton has labeled here as being only for 3-way installations, and that's going to connect to an additional wire that's associated with the lighting circuit. Like I said, in my case, I don't have a 3-way switch, so I'm going to ignore this wire, just leave it disconnected, and I'm going to connect this one red wire directly to the wire going to the cans. Next up is the fan control. Now remember, we have 2 hot wires going to the fan so that we can independently control fan speed and the fan light. On the switch here, the red wire is for the motor and the yellow one is for the light. So I'm going to connect the red wire to this red wire, and I'm going to connect the yellow wire for the light to the black. Now I could reverse it, the choice is arbitrary, but it just makes more sense in my mind to connect the red to the red. It just makes it more clear what's going on. And lastly, the switched outlet. I just have to connect this red wire, which carries power to the outlet that is switched, to this screw terminal here. And once that's done, I can put everything back in the box. Alright, as you can see, the recessed lights are in and they're working great, which means that this install is just about done. The only thing left to do is to install the trim once the drywall is finished and the ceiling is painted, but that's not going to be for a while, so for now I'm going to leave it here. As always, I hope that you found this content useful and that you learned something, and if you did, please like and subscribe.